Welcome back to STS. In today's video, we're going to find the equation of the tangent line to the function shown here, x to the third plus y to the third is equal to 9, and we're going to find that the line that's tangent at the point 2, 1. In a previous video, we've done the same problem, but we've used implicit differentiation. Today, we're going to solve for the variable y and actually use standard differentiation to make sure or to show that we still come to the same conclusion. I'm going to begin by subtracting x cubed from both sides. Alright, in doing so, the x cubes here on the left hand side cancel out, and I'm left with y to the third is equal to 9 minus x cubed. At this point, I want to solve for y, so I need to take the cube root of both of these equations here, or both sides of both of these expressions. So the cube root of y cubed is just y, and the cube root of the other side stays the same, but I'm going to write it in a different form so that it's easier for me to put into the calculator. I know that the index here is 3, so that's my denominator, and this expression here is understood to be to the first power, so that becomes my numerator. At this point, I want to take the derivative of y, so here y prime, I'm going to use the power rule. This 1/3 comes down to the front as a factor or coefficient in this case. Then I'm going to rewrite everything inside the parentheses, 9 minus x to the third, and I need to subtract 1 from 1/3. So that's really going to be 1/3 minus 3/3, and then I need to multiply by the derivative of the inside, and here the derivative of 9 is 0. The derivative of negative x cubed is actually negative 3x squared. So now at this point I need to simplify. I've got 1/3 9 minus x cubed, and that's going to be raised to the power negative 2/3, because the 1 minus 3 gives me a negative 2, and I keep my denominator, and I'm going to rewrite this second factor here. At this point, oops, and also say I made a mistake. This here shouldn't be a 9. This here should actually still be a 3. Alright, what I want to do at this point, I see I have a negative exponent, so I'm going to move this negative exponent to my denominator. So here I have 9 minus x cubed, and this time it's going to be raised to the positive 2/3. In my denominator I should have a 3, and in my numerator I'm left with 1 times this quantity here, and that's the negative 3x squared. At this point I see I can do some more simplification. These 3's cancel, so I'm left with a negative x squared in my numerator, and my denominator is 9 minus x cubed raised to the 2/3. Now at this point I want to substitute in my x value of 2 so that I can find out what the numeric value is for the derivative. This here is just my expression for the derivative. I'm going to change my notation a bit. I'm going to go to my f of x notation. Here I'm going to put in f of 2. So everywhere there's an x, I'm going to replace that with a 2. So I have negative 2, a negative, then I have 2 to the second power over 9 minus 2 to the third, and I'm going to raise that there to the 2/3 power. Well, 2 to the second is 4, but I keep my negative out front. Here I have 2 to the third, which is 8. So this here is really 9 minus 8 to give me 1, and that 1 is raised to the 2/3. And I know that 1 raised to the 2/3 is still going to be 1. If I were to write that out, that's really the cube root of 1 squared, which is just the cube root of 1. And we know the cube root of 1 is just 1 times 1 times 1. So this denominator here is just 1. And then I have negative 4 divided by 1 to give me a slope of negative 4. At this point, I want to write the equation for the tangent line, and I'm going to use the slope-intercept form to show that. I have the point here, which is 2, 1, and I have the slope here, which is negative 4. So the form of that is y minus y sub 1 is equal to m times x minus x sub 1, and this here is where x sub 1 and y sub 1 are the point in question. So here I'm going to write y minus y sub 1 is a 1 is equal to the slope, which is negative 4, times x minus x sub 1, and here we see x sub 1 is a 2. At this point I want to distribute on the right hand side, so I have negative 4x plus 8 because a negative times a negative gives me a positive. And now to isolate the y, I'm going to actually add 1 to both sides of the equation. Alright, in doing so, these ones here, the positive and negative one, cancel, and I'm left with y is equal to negative 4x plus 9, and this here is in fact the equation for the tangent line. Now that we've done everything analytically, let's go to the calculator and prove everything geometrically. Alright, let's go to the calculator. We want to press the y equals button. You'll notice that I already have the function here in place, the quantity 9 minus x to the third raised to the 1/3 power, and I want to go ahead and graph that. So I press the graph button. Here in blue is the graph. It's drawn in place. I know the point positive 2, 1 is in the first quadrant, so let's just zoom into that area. So we click zoom, and then let's press alpha, and then press the math button so we can get to A, which is how we get to the first quadrant. And I see here that basically my largest x value, that so I can zoom in, I'm going to use the x value of 3 and also a y value of 3 just so we can zoom in on this area here. So I'm going to press window. I'm going to go down to x max. I'm going to put in a 3, and then I'm going to arrow down to y max and also put a 3 in y max, and again I want to graph. Alright, now we've got a much closer view, and like I said, the x coordinate is 2, the y value is 1, so we're looking for the tangent at the point here. But let's use another function of the calculator. Let's go to second and then press the program button so we can get to draw. And if you notice, as we go down to option 5 says tangent, so we're going to go down to tangent and press enter, and the calculator is going to ask us to put in our x value. But first let me change the style. I want to make sure the style of the line is different from the blue that we currently see. So I press the graph button. Let's change that style to, let's go to red, and then let's press enter to accept that. Keep the line style the same, and OK. Now I want to press the number 2 and then press enter, and we're going to let the calculator calculate where that line is supposed to be. Oh, and one other thing I want to do, let's go to mode, and under mode where it says float, let's change it so that it's not a float. Let's put it so that the calculator rounds to 3 decimal places. And then let's go back to graph and let's do this one more time. So let's press second and then program so we can get to the draw method. Press number 5 to get down to tangent. Let's change the style again. I'm going to hit graph for the style. This time let's change it to, let's do black so we can see that redrawn in. Press enter to OK those settings, and then I'm going to press the number 2 for that, the 2 for the x value, so that it draws the tangent at that point 2, 1. So I press enter, and that red line should go black. And if we look at the equation for the tangent line, we see that that is negative 4x plus 9, which is the same thing that we calculated by hand. Y is equal to negative 4x plus 9. Alright guys, that sums up this video by Speller Tutorial Services. Please friend us on that Facebook page and also subscribe to our YouTube channel. And as always, thank you for watching.